Alrighty, good afternoon, good evening. Thank you for joining. This is going to be a recomplete of Lab 9. During the completion of Lab 9 earlier, there was a few things that I had left open, as well as during the recording, there was a few hiccups that I just wanted to be able to correct with just a single video, and it just goes to show, not everything necessarily goes perfect the first time. But I did want to go through some of those things and correct them for those who are watching it diligently. So for this lab, I am going to start it just from the beginning again. So for lab 9, what we're going to be doing is we're going to be configuring two PCs, PCA, PCB. We're going to be very lightly configuring a switch, and we're going to be configuring IPv6 routing on R1. So there's no IPv4 being used in this network at all. We're going to be utilizing the globally unique IPv6 address, the unicast specifically. So we're using the 2001 DB8, which happens to be a private slash 32, I guess is what it would be, address that's basically ensures that you can't use it in a real live environment. It's just used in examples, basically. However, obviously, you would see that this is a /64. So pretty much what's going to happen is our global routing prefix is going to be the 2001 DB8, and our subnet prefix, or subnet bits, they're going to be the ACAD A and the ACAD 1. And then we have the extra little bit there. And then we have our local link IPv6 address, which is the FE80. So we'll talk about that in a bit as well. There's two different ways that gets configured. So let's see. We configure host name. Nothing really crazy on this one in terms of base configurations. But we can talk about some other base configurations that you could end up doing. In this case here, it just says the host name, which is kind of very light. And there's much more that we can work with. We can also go through here and we can configure our interface. So we're going to configure that unicast, the global unicast address, the 2001 DB8. And we're going to be assigning it the host of 1 for both of those. And the no shutdown, so we're going to bring those interfaces up. We're then going to examine the interface. Now, one thing I had brought up previously was that this picture here is actually a picture that was taken farther into the lab. Part of that has to do with the fact that we can see here how it's using our static configured FE80s rather than the automatic configured ones using the stateless auto configuration, the SLAAC. And that's what it talks about here. It says, hey, check this out. We can see it's using the stateless auto configuration, but it's actually not. And it's not because this picture doesn't belong where it is. It actually belongs down here, farther down the list. And in next, we go in there, and this is where we actually configure our link local static address, so we're not using that stateless auto configuration address. And then we look here, and funny enough, this picture is also in the wrong spot. Mainly for the fact that it's showing the IPv6 interface, rather. And we can see here that it actually has the multicast grouping of the FF02:2, which represents that it is a listening router, which means IPv6 routing is turned on. But if we scroll down farther into the lab, we would actually see that IPv6 unicast routing isn't actually turned on till after the fact. So, interestingly enough, that kind of, like I said, this the FF02 :2 doesn't actually exist where it's in this picture, at least. We're going to save the configs, do a little dance and song and dance, take our picture, because see, now we can see that this actually exists now. So obviously the picture was in the wrong place. And then we're also going to need to make sure that our PCA and PCB get their automatic IP addressing using that stateless auto configuration, which is how we're going to be able to answer this question where it talks about the global routing prefix and the subnet ID and how it came about. And then in the switch, we are going to need to configure our VLAN 1 with our static unicast address. So the 2001 DB8 being the global routing prefix and the ACAD 1 being the subnet ID. And then left over at the end, we have our host identifier, which is letter B. And then we configure our link local, same thing, the FE80 :B. So we're doing that instead of allowing that stateless auto configuration to be used. And then there is one other thing that was actually missing, and I'd mentioned it when I ran through this before, but this section here, you actually need to enable the VLAN interface using the no shutdown command. During the configuration, I can't remember if I actually did it automatically or if we ended up seeing it in the end, but that is something that we need to make sure we address. So then we can do our show. And yeah, so I'm going to actually still follow that to the T so we can see that this doesn't actually result in what it was. And then here we're going to assign static IPv6 unicast address to this rather than using our stateless auto configuration. But that's actually what we can even see here with our link local. We can see the FE80, and then we can see the double FE representing that this is part of the stateless auto configuration. And I'll talk about that when we get in that step. So that's that part. And then we're going to do our little ping around, ping back and forth, ping from the PCA. And one other thing that we ended up coming across earlier was when I was trying to ping from PCB to this switch wasn't working. And part of the reason why it wasn't working is because I didn't configure a way for it to get outside of its own network. So it needs that default gateway to get out. So we can configure a IP route on this switch. From what I could tell, there isn't any real direct way of configuring a default gateway the same way you would configure a default gateway with IPv4. And some more pings, and yeah, that is that. So let's get started. And then I guess the other interesting thing too, actually, is the fact that I don't know if it's necessarily a typo, but that I'm pretty certain should say SLAAC, which is a stateless address auto configuration, not SLACC. So typo for the win. So going back to the beginning of the lab, we can go ahead and set up our scenario. So in this case here, NPC, NPC, and then we're going to go ahead into our switch department. And in our switches, we need to go ahead and drop a 3650. 3650, and we're going to go ahead and drop our router. Our router it's looking for is a 4321. 4321. Now in this configuration, it does get us to go ahead and connect it all using just straight throughs, which, you know, we could do. However, the other sort of catch is the fact that, you know, between the router and the PC technically should be a crossover. However, the router is auto-sensing. So it actually has the ability to convert the pinnings on it. The other thing also that we ended up discussing previously was in the image, it talks about it being Fast Ethernet 06. However, this particular switch we're asked to use is actually all gigabit. So the one we're looking for is we're going to just basically append the one in front of that. So it's going to be gigabit 106. And then this side is going to be 05. And this is going to go to gigabit 1. And then we're going to follow the quote-unquote proper Cisco world. And we're going to use our fun little crossover. And then let's just change these names really quickly. So PC-A. And then on this side, PC-B. And then this one is going to be our R1. And this one is going to be our S1. So now that we have that all in play, we can go ahead and do some configurations. So on the R1, we can whip open the console, CLI. Now, I don't know why it always asks about that. Well, I do know why, but initial configuration dialog is one of the most useless things. Never going to use it. Enable config T. We're going to global configuration mode. Hostname R1. Sounds good. Now it only asks for us to configure that for basic settings, but let's just go ahead and finish up the rest of the stuff. So we can configure our line con 0, password Cisco login for simple password authentication. Looking at that Cisco, we can do our line VTY 015 password Cisco. So we're configuring 16 virtual lines. Now, the other thing you can do as well, if you didn't want this to kick you out, we could actually use our command exec timeout and basically say that we don't want it to actually time out. Exec timeout 00 basically just means never timeout. And then the other thing we can do is we can also add another command in that I've forgotten about originally, and it's actually quite beneficial and useful, logging synchronous. You probably had it before where we turn on and on interfaces, and then what ends up happening is the command sort of gets buried in between mass amounts of output. So the idea behind logging synchronous is that if you have output to the console, it's going to basically push it before or after your command so you can see the entire command. So it's not basically mid-sentence. So we got those things there. We can go back now. Exit. We can do our banner MOTD $. No unauthorized access. Okay. So we got that. We can even do our no IP domain dash lookup from before. That's really all we've done necessarily in class. There's lots of other things that we can do, but like the exec timeout, I know some of you would probably enjoy that. We can also do our enable secret, I guess. Forgot about that. Class. And we can do our service password encryption. And I would say that's probably going to be what I would refer to as basic device settings, everything that we've done so far. So let's go ahead and do our interfaces. So interface G000, IPv6, address 2001, DB8, CAD, A. And what this basically means, and as I mentioned before, the /64 represents the fact of, and that's going to be basically what you're going to usually come across. Windows, when it's a /64, will automatically perform that stateless auto configuration. So it's typical that you're going to be dealing with a /64 in the endpoint. But a lot of times you're going to be assigned a /32 as an example, which is these first two octets. So this being your global routing prefix, and then this ACAD A's, these two sections are going to be your subnet portion, your subnet bits. Now, one thing this can be expanded into is we can actually so we got 1, 2, 3, 4. Okay, let's just drag that like that. Okay, let's see. 16, 32, 48, 64. Yes. So 128. Perfect. So that's effectively what it gets converted to. So these zeros in front of a number we can basically remove. Let's just do it like this for a second. So we're allowed to take away these leading zeros. And then when we find a group of zeros, we're allowed to actually replace this with 1 double semicolon. And then the /64, the prefix length, is basically just saying that this portion from the A, from the beginning of the address, is all going to be part of the portion of the address that's not going to change. So we can configure that. We can do our no shutdown. And then we can go ahead and we can configure our other address, making sure we actually change interfaces. We found this out earlier today. When you don't pay attention and you don't change the interface, what ends up happening is you actually have to do a no IPv6 address to remove it all before you can reuse it, obviously, on a different interface, because of the fact that it can only exist on one interface. You can't have addressing overlap. So now we configured that, we can go ahead and do our no shutdown. Perfect. So what it wants us to do is run the show Ipv6 int brief. So what we can see going on here is we have our statically assigned interfaces, that being Giga 000 and Giga 001. We see we have our global unicast address, the 2001 DB8 ACAD 1 and 2001 DB8 ACAD A. Remembering that the first portion of this is our global portion, so that's our global routing prefix. And this second portion is going to be our subnet. And then the last bit that we can see here is basically our interface address that was assigned to the host ID. We can see here that our interface is down, and that's actually because the 3560, as we found out earlier as well, you actually got to check a power supply in it for it to turn on. And you know what? While we're waiting for it to turn on, we can even check this cute little metal thing over top of the extra spot. That way we're covering it up. Don't want to have any mistakes. Wait for this to come online. Cool. So it's almost there. Sometimes if you want to make these links speed up quicker as well, you can cycle between simulation and real time a couple times, and that will also help speed up these links pretty quickly. Now, one thing I did want to do, so we got our picture, and if you want to, I guess, have a better picture, now that they're online, we can do this, and we can see that they're actually both up and up. So that would be the screenshot that it's looking for. So next up, we're going to statically configure our link local addresses. So we can do our config t, interface G000, IPv6 address FE81 link local. So that's basically defining, we're setting our link local, which is kind of obvious from the fact that it is FE80, and then the double colon and the 1. Now, the one thing you'll notice is that both of these actually have the same address. However, that is allowed for the fact that the link local is, as the name sounds, it's not a routable address. It's only applicable for that side of the link. So these numbers are quite honest. You're probably going to see them quite often. The one thing that is talked about in the book, however, is that when you're configuring the link unicast address that are actually routable, that it mentions that you should still, even though the fact that you're not routing them, you should still follow some procedures in case you ever decide to merge companies, that you're not all utilizing the same, nondescript IPv6 address. So we have those now configured. And we can go ahead and do our show IPv6 interface. And sure, we can look at the specific interface. We see that it's up and up. We see the link local address has been defined. We see we have our global unicast address is defined. We see the subnet. There we go, the /64. It shows what part of it is the subnet and what part of it is the actual host portion. And what you'll see here is there's something missing, that FF02:2. And that's that thing I was mentioning, is that that address is missing because we haven't actually turned on routing, therefore it's not going to be there. What is there, however, is we have the multicast address, the FF02:1, which is representing the fact that it is a node, it's an interface that's listening on the link, so it has that one. However, if a device just trying to use stateless auto configuration to configure a global unicast address, it's not going to happen. And we'll see that in a second. So yeah, so you can submit your screenshot of this. And like I said, funny enough that it's not actually that. Open PCB. IP config. We didn't get anything. It's because it's set to static. So let's fix that. Slap these puppies into automatic. And we're going to see that the request fails. If you're wondering why it fails, we can open up the simulator panel, and toggle it from static to automatic. We can then see that the PCB is trying to perform the neighbor discovery protocol, the NDP. So we see here that it's formulated a package. Its destination is that multicast, the FF02:2. We already know that it's not listening for those router solicitation messages, right? That's what we discovered already. Even though the screenshot in the document says it was, it's not. So it doesn't have a IPv6 unicast address assigned to the interface. And we can see that, and if we go back, closing this, we go up to our command prompt, and we can run this command again. We can see specifically we only have our link local address configured. So now we can go back to our R1 router. We can go to config T. We can run our IPv6 unicast routing. Go back, do our show what do you see? We see it's now joined as a router solicitor. So it's listening on that multicast address, the FF02:2. So that's pretty cool there. And now we can see these NDP messages going on in the background. So I'm actually going to click that off for now because we obviously know something different is going to happen. So let's go to our IP config, and now we can see that request has actually come through successfully. So we're going to look at the rest of this from the command prompt because I want to show you something different. So if I run the ipconfig/all, what you're going to see is that we have a physical address of 00E0F9 for the organizational unit, and for the unique identifier for the interface, 97A9B3. The reason why I read it out that way is what's going to happen during this stateless auto configuration process is we're going to see this FE80. We're going to do the double colon. And then you're going to have to trust me on this for a second. This is the first part of the MAC address. And then we have the E0. And then we have the F9. And then we have the double FFE that gets slopped in the middle. So the double FFE. And then we have the 97A9B3, 97A9B3. So effectively what's happening during this stateless auto configuration is this first portion of the MAC address is actually being converted to binary. And the second to last bit from the right-hand side, so the 7th bit, or the second bit, depending on which direction you want to look at it, gets inverted. So if that bit's a 0, it's a 1. If it's a 1, it's a 0. So in that case, it turns this into a 2, basically. And the leading 0 gets dropped off of this. Can't delete the trailing 0, however, because it'll change the number altogether. But the leading zeros, those can get dropped off. And then there's a grouping of zeros here, and that's why we have the double colon in this position. You can only use one set of double colons in an address, so you can't do it twice. So you want to pick whatever one's the largest amount of it, but technically there is no wrong answer as long as it's used once and it replaces a grouping of multiple sets of zeros. One other interesting thing, actually, when I was reading through the book, is they refer to these groupings of numbers as quintets, basically. But you know, I'll just refer to it as a IPv6 grouping, anyways. But and then we see here for our IPv6 address that went through that same stateless auto configuration for our unicast. What do you see? Well, you see that portion of the address, the global unique identifier, the G bits, or whatever you want to refer to them as. And then we also see the subnet portion of it. So we have the 2001 DB8, and then for the subnet portion, the ACAD-A, and then we have our stateless auto configuration section that's getting slapped here at the end. So it's taking the first the first portion of the OU for the MAC address. It's inverting that second last bit, the 7th bit, and then it's basically putting the double FE in the middle of it. So we got that going on. And then we still have our IPv4 address that's happening here. So that's one thing that you definitely want to watch out for if you are going to start utilizing IPv6 only, or you happen to, maybe you decide to get rid of IPv4, or maybe you decide to start implementing IPv6. You got to remember that it's a different protocol. So you need to make sure you configure everything twice. So that's it for the addresses, I think. Let's see, is there anything else I wanted to cover with the addresses? Basically, if you're wanting to know more about these, the global routing prefix, it's the first chunk of digits. And then the rest is the subnet. So I guess technically in this case here, while the 2001 DB8 is a /32, it does mention in the book that the global routing prefix that's assigned is a 48-bit section. So I guess we could look at that then as the global bit, and then we could look at the A as the subnet portion, and then the rest as the host portion. That's sort of defining it. But we still, like I said, see that same thing, the double FFE97A9B3. So we know that it's utilizing that stateless auto configuration. So we can go ahead now on our router, and we can do our copy run start. That way we don't lose anything. And so yeah, so why did PC receive the global routing prefix and the subnet ID? Well, it has to do with the fact of neighbor discovery protocol. So you'll have to read up in on that and the neighbor discovery protocol and how it communicates, but we just discussed all that. For our switch, let's go ahead and do the similar. So let's go config T, hostname S1, service password encryption, enable secret class, minecon 0, password Cisco. It's the same things basically we go through. Setting the line console thing, we can do our exact timeout so it doesn't time out on us. We can do our logging synchronous so our messages don't interrupt us. We can do our line VTY015, so our 16 lines, password Cisco login exact. Oh, it helped if I spelled exact right. Exact dash timeout 00. There was even some other commands as well that I had read up on, like this, the history size, how you can actually define how many commands it stores physically in the history buffer and stuff like that. So all sorts of like little fun things like that. The history information, or more information about the commands, you can actually find in chapter 5, I think is what it was. Chapter 3. No, it was chapter 6 actually. So chapter 6 brings in a whole bunch of fun commands that you can go through to your heart's content and play around with. So yeah, so we've configured that. We can do our banner MOTD. Okay. So what we're going to do now is we're going to configure our interface here. So we're going to do our interface VLAN 1, IPv6, address 2001, DB8, ACAD 1, :/64. So we're configuring our global unicast address there. IPv6 address FE80B link local. This is going to be. And then we can do our copy run start. Fantastic. And it wants a screenshot of the show IPv6 int VLAN 1. Now, one thing you will find out a lot of with these commands is that the IPv6 and IPv4 4 are not the same commands that we're using. So a lot of them are just IPv6 instead of just IP on their own. So we'll see here that it still is administratively down. So that's what I had mentioned before. So let's just go ahead and kick that interface up. Interface VLAN 1, no shutdown. So we can see how this message is basically kicking our prompt and it moves it down. It's not interrupting and having it pasted smack dab in the middle. And that's logging synchronous is the command that solves that problem for us. So we can do our, let's do end, kick us all the way back. Another good nifty trick, the end command that I've found out rather than just doing exit a bunch of times. Show IPv6 int VLAN 1. So now we can see it's up and up, basically telling us that this virtual interface is online and that it has a interface that's actually up associated with it. So we got that, and you can see here the difference because it's not a router. It's only listening on the FF02:1. We don't have that FF0202 like we do with the router. So now we can actually go ahead and assign static IP addresses. So we can go ahead to our desktop, go to our IP configuration. See, this actually already had static, but we'll fix this up real good. 2001 DB8 ACAD 1:3, and it's a prefix length of 64. And for our default gateway, lucky ducks we are, we can actually just configure this to our link local. So that's now configured. We can go over to the other side and we can do the exact same thing over here. IP, so see we got our IPv6 thing, but we're going to kill that. We're going to do our 2001 DB8 ACAD A3. You'll notice that they're both 3s. FE81. Perfect. So now if we go to our command prompt and we do our ipconfig all, or we can do the IPv6 config, we'll see now that our we have a IPv6 address that's actually statically assigned. It's not configured through stateless auto configuration. And we know that because we don't have that FFFE smack dabbed in the middle of our addressing as well. So what it wants us to do is it does want us to actually issue the other command. So let's just issue it, IPv6 config. And so from here, you can see the information about it. So that's okay. IPv6 config. Same thing. We see that the unicast is our manually configured one. It is not the stateless auto configuration because we don't see that double FFE smacked in the middle, similar to like we see over here with the FE80 for our link local, how that's statically, or that's being configured through our stateless auto address configuration. Stateless auto address configuration, SLAAC. So now we can go ahead and do a ping. So it wants us to ping the switch management interface from PCA. So we can go ahead and do a ping DB8 ACAD 1B. And we see we get nice up and up. It wants us to tracer T to PCB. So let's do that. Tracer T to its global unicast, otherwise it wouldn't work. And we can see it makes its way there. So no problems on that regards. And that looks like what we're supposed to have. We can do our ping of the same thing, but we're actually going to, oh, we're going to do the other way. Yeah, probably help if I pinged PCA from PCB and not PCA from PCA. 2001 DBA ACAD 1 3. So we see that goes through successfully. And from PCB, we're going to ping the link local address of G0001. Sure. Let's do that. Ping 2001 DB ACAD A. Oh, did I mess up something? I did. It would help if I put in the full address. DB8. There we go. So that went through successfully. Now, one thing I ended up doing last time, and I couldn't figure out why for whatever reason, for the life of me, it wouldn't work. You know, kind of funny that after all that playing around, I still couldn't, I still didn't see it through. But what we're going to do is we're actually going to go ahead and we're going to ping this from PCB. So what ended up happening was we went through here, we slapped in, oh, that's not going to be my... So let's go ahead and ping this. There we go. So we're going to ping this, and it's going to fail. And the reason why it was failing last time was basically kind of what I was expecting, but, you know, it just, I guess I knew what the answer was, I just didn't know, and it was kind of funny because I was literally driving, and all of a sudden I was like, oh my goodness, it's default gateway, and it's sort of default gateway. It's basically that the switch doesn't have any way to get information back. So what we can see is if we turn on the simulator, and let's go ahead and do this ping again. We can see the ping going from PCB to R1. We can see the R1 going to SW1, and then it just stops. So what we're going to do is we're actually going to go ahead and stop this playback. We're going to click on the ICMP, the PDU from when it just disappeared, when it hit SW or S1. So we see here. So there we go. It's at R1 to S1, and then you see the packet goes whoosh, and it just blows up on the spot. So we see it's in, and then it goes to go out, and we can look at this information, and it basically says, yes, the destination looks right. Nothing's wrong there. It's responding to this ICMP-v6 echo. So we're reading this, okay, it's responding. The device encapsulates the packet, looks for the destination IP address in the routing table. It doesn't have any information on how to get to it, and it just chucks the packet into the bit bucket. So effectively what's happening is that this S1 can't get back home. And we're going to help it along. It's always nice to help things along. So the way we can actually correct this issue is if we go into config T mode again. Now you might be, reaching to do that whole, IP default. What is it? Default gateway. IP, yeah, default. So you might be reaching to go through and do this, but what you would find is if you do the question mark afterwards, it's looking for a IPv4 address. So it's not so easy after all. However, what we're going to do is we're going to use the IPv6, and you would see if we did IPv6 and do a question mark, you'll notice there's no default gateway there. So we're going to do an IPv6 route, and we're going to define that if we're trying to get to that specific network, how to get there. Or we can define it as a default. It doesn't necessarily matter too much to any degree. So we can do our 2001, and then we can do our ACAD. And which network was it? Oh, I missed the DB8. DB8. ACAD A, and it was a /64. And we're going to have to put in the actual IP address of the interface. So if we try to label this out as FE80::1, when did I mess up on? Oh. Yeah, I still got to put in the host portion. So $:0, but it says the interface, in order for it to actually work, we actually need to supply the next hop. So we're not allowed to just use our link local there. So with that being said, let's do that. Pull this over here like that. I'm a big fan of this whole right-click, copy, paste thing. Works pretty well. And we're going to right-click, copy, and paste. And there we go. So we go back, we can do our show IPv6 route. See, like I forgot to enter something there, but let's see, what have it done, or what hasn't it done, rather? Did I mess something up? Never trust me sometimes. DB8 ACAD A. Is it looking for something smaller? So instead of a /64, let's go with a 48. Show IPv6 route. Interesting. Well, let me just put this back into real time for a second. See what's going on, because there's two different ways you can configure this, and I'm wondering if it's just not happy about the way. So I may have to do it the other way, which is with the interface. It's funny because I tested this out actually before, and it was working, but it's just trying to be a pain, clearly. IPv6 route 2000. 2001 DB8 ACAD. Let's just see something. I think it wants me to configure the actual interface. I think that's what it's mad about. It doesn't want the next hop. It wants the actual interface that it wants to send this out. So let's just try that instead. And I'm not going to retype that all out. Are you crazy? So G0105 6 route. This is crazy. It's like it's just trying to make a mockery of me. 64 G105 6. Okay, let's just try to see if we can just ping it and see what happens. But it's definitely not showing up like it was before. Maybe I'm missing something still. Ping 2001 and DB8 ACAD A 1 1. Okay, so it's able to ping our default gateway inside interface. Can it ping the other side of that? It's not going to. So there's still something that it's not happy with. Show IPv6 interface brief. FE80 :B 2001 DB ACAD 1B show IPv6 VLAN 1 VLAN interface VLAN 1 so that's correct. And it's facing the number 5, I remember correctly. Yeah, it's Giga 105. Am I configuring something else wrong? 2001 DB ACAD. Like, I guess the only other thing we can try, maybe it doesn't want that specific network. 0/0, and we can paste in that other address. Is that actually the right interface, though? Let me just double check and see. Oh, that's what happened. It looked like I actually might have inputted the wrong interface. So let's actually put in the right interface, and bet you this is going to work. Show IPv6 route. There we go. Now we got our static route. And our ping is most certainly probably going to work now. There we go. So, from our PC, we can come over here now. And we can actually go ahead and we can ping, not for PCA, I want PCB. And we see our ping is now going through. So it was actually a nice little troubleshooting exercise. Basically, it was the fact that I ended up entering the IP address after all. So if we do our show running config, we would actually see, yeah, the only one that really mattered in the end was the one that I did correctly, which is kind of funny. So yeah, so it didn't want that. It actually physically wants you to enter in the next hop, but of course you have to actually enter in the next hop correctly. And you would see here when I copied them, I actually ended up doing them the wrong way. So we should probably actually go ahead and remove these incorrect ones, so we can go ahead and highlight them. Gonna copy them. Open up another new window. Let's see, Notepad. Notepad is your friend. Let me tell you that. So Notepad, you can go ahead and type in your no's. No. copy, get into the right configuration mode, paste, bam. See, just like that, show run. All those routes we don't need are now gone. And if we do our show IPv6 route, we will see we still have our static entry in there because we actually have now configured our next hop IP address correctly. So that's all we need to do. So copy, run, start, save that, of course. And yeah, that was the end of this lab. Like I said, it was a fun and exciting lab. And there's nothing really else to go over. So if you have any questions about IPv6 or any issues, feel free to post them in the comments below. And in next week's lab, I'm sure we'll be going over more IPv6. We can discuss a whole assortment of things, especially for the fact that we're dealing with static routing. But one thing really just important to remember, when you are dealing with the IPv6 routing, remembering that you have your global routing prefix, you have your subnet portion of it, the prefix, so that's usually 16 bits on top of the 48 bits. The fact that the 2001 DB8 is a global unicast address, however, it is specifically non-routable, so that's just something to remember. But you always want to get your interface ID portion, the host ID portion, to 64 bits, because if you have it that way, stateless auto configuration will function correctly, and you won't have any issues in that regards. And then in terms of your other addressing, the fact that the FF02:2 represents the all router multicast listening address. So when we ran that IP routing, the IPv6, so we turned on the IPv6 routing, that was kind of one of the steps we had to do. If you don't run that command, IPv6 routing will not be on. You have to configure it on the router for both the interface and the router. So if you're wanting to utilize the link local only and you don't want to configure the unicast, then there is actually a command you can use. So if you go into the router and you go to the config T, interface G000, I believe it's just IPv6 enable, yes. So IPv6 enable would be how to enable it on the interface if you didn't have any plans of statically configuring a unicast address. So if you just wanted to utilize the stateless auto configuration of a link local, then simply enabling the routing on the router and then enabling the router on the interface using that IPv6 enable command is all you need to do. When you're converting your addresses, writing them out, remembering that you can remove leading zeros, but you can't remove the trailing ones. So when we looked at our one address, here, remembering that groupings of zeros can all be removed and replaced with this double colon. So if we looked at this address here, remembering that our address is 128 bits. So FE80, and then it would be 0, 0, 0, and that would represent the first half of the address, that being the global routing prefix, as well as the subnet portion. And then we would have the other portion, which is the interface ID. So 1, 2, 3, 4, 1, 2. It would look something like that. And then if you actually wanted to fill in all the other zeros, it would do something like this. Oh, one too many there. One too many there. So it would look something like that in the end. And then we would add our /64 as an example. However, because we're allowed to, we can remove our leading zeros so that there's 1 0 left in every single quintet, as the book would say. And it's left like this. And then what happens now is, well, now you can go ahead and delete all of the zeros in one single group and just replace it with a single double colon like that. So FE80 double colon 1, it's, you know, it's /64 is what it would end up being, because it is a link local, and the first portion of the address is basically non-addressable. When you configure it, though, actually, you don't need to configure the prefix number for the link local. It's just specific when you're configuring the unicast. Or quartet. Quartet is what they call it. But yeah, other than that, I think that sort of solves probably most, if not all, of the questions you may end up having from this lab, as well as sort of some background knowledge and information from the IPv6. So hopefully this recompletion of it does help clear up some questions, as well as also fixing that that pesky ICMP version 6 not wanting to function. If you're, if you can't ping, just check the VLAN interface on your switch, make sure that it's up. And other than that, you're good to go. Take care and have a good rest of your day or evening.